Okay, 5-9 is going to carry on with our factoring. And so far, we have had essentially, for the most part, we have had this coefficients of 1 in front of my squared, or in front of our squared terms. Now, we also dealt with perfect squares, like difference of squares, perfect square trinomials, and those ones did not have coefficients of 1 necessarily, but we were able to deal with them. So if we review a little bit, so 5-9 is going to be factoring, but our pattern for ax squared plus bx plus c is just a general where the coefficient may or may not be 1. So it ends up being a guess and check method is what I call it, ax squared plus bx plus c. So let's do a brief review though. Start with DOS. I'll give you a DOS one, and if you have, let's go with 16z squared minus 121. Go ahead, factor that DOS. Then we have a PST. I'll give you. So these are just a couple little review problems. So factor those three. I labeled the first two as specific, like kind of specialty ones we did from 5-5 and 5-6. And then check with your support team around you. And say, hey, support team, what did you get? Jive if you don't have a team. You can whisper to your imaginary friend. Haspa. Who usually sits there?
Colby. Right here?
No.
Ella?
Yeah, Alice.
Okay.
Hello. Where is she today? Wasn't she here? Oh, wait, no. She has strap.
Oh. Okay.
No.
She has what?
How do you know?
Because I talked to her.
Why was everyone so sick? I don't know.
We're all gonna get it.
Sure sucks.
What do you have?
Yeah. Twice.
Coronavirus. Oh, corona.
I remember that.
Okay, here we I remember that. Okay. So hopefully DOS, you should be hopefully kind of done with DOS, looking at the PST, then factor that one. These ones are fairly straightforward. You may struggle with them a little bit, but fairly straightforward. Not too complicated if you've been tracking with what we've been doing. Again, if you struggled with 5-7 or 5-8, what should you be doing? You should be getting help right now, not waiting until test time to figure it out or mid-chapter assessment time, which, what is today, Wednesday?
Yep.
Tuesday. We'll probably have a mid-chapter assessment. Oh, who's going to be gone Friday? Just Bergen
Monday.
and Eden?
And
Bergen, Giselle, Eden, and Harrison.
Okay.
Who's Bergen?
Who, Bergen?
Wait.
So either our mid-Casper, mid-Casper assessment.
That's what you should call it next time.
Chapter assessment would either be 5-7, 5-8, 5-9 happening on Thursday,
This Thursday?
or we could do one Monday.
You know, we should do it Thursday if it's just some
Next
three. Then we don't have to like study. over.
Prepare as much.
Yeah.
Do we want one? You want one Monday?
Yeah, 'cause then we can study.
Then you can like double down and study and have it be over 5-10, 5-7 through 5-10.
No.
Oh, what?
I like
5-7,
the
5-8, 5-9, and then 5-10.
No.
Wait a second. I think we should just do the three.
I think we should just do it tomorrow, so it's just 5-9.
Oh, that's true. No, I think we should do it Thursday over 5-7, 5-8, and 5-9.
Wait, why can't we do it Friday?
Well, we're gonna have Bergen gone, Eden gone.
Oh,
Who else gone?
basketball.
Harrison and Giselle.
Giselle, Harrison. It's just then they have to come back and then figure out when they're going to take it. And, I mean, they may be gone anyways for
It's a whole
sickness.
problem.
Who knows?
Why
Okay,
do you have
who else is on the basketball team but just not good enough to be gone? You can never just ask a kind question. You have to ask a question with a jab. Nobody else is on the team though?
No.
Just those people that are here and leaving. Interesting. Okay, cool.
Only people this
So
question.
let's go with the DOS. The DOS goes like this, right? Factor, factor, factor. And we say, what times what gives you 16? 4, and then Z, 4, and then Z. And then since it's a DOS, we know it's a minus and a plus, 11 and an 11. You tracking with that? Okay. Most people are doing fairly well with that on the test. Some people are trying to factor out something out of these two, which at times there is something to pull out, but in this case there's nothing to pull out. You just do the DOS. Here, what's interesting, this is a perfect square trinomial because you say x and x, and then what is 81? 9 and 9. So, and then it was minus minus, right? But with that, so you could rewrite that as x minus 9 squared. So the interesting thing is this actually falls into the category of the 5, 7, and 5, 8 kind of conversation of if the coefficient is 1 in front of the square term, you can say what times what gives you 81, added together gives you 18, or in this case negative 18. And so it's really, if you forget the perfect square trinomial method, it's really okay because you can just do the factoring and then check it and say, oh yeah, it works by giving you those values, the same way we would do with this. So what does this one factor out to be?
X plus 2, x plus 3.
X plus 2 and 3. Now again, this one is not a perfect square trinomial, but we ask the question, what times what gives you 6, added together gives you 5. And we don't have to worry about anything for the x's because it's a coefficient of 1. That's really nice. What happens in 5, 9 is the coefficients aren't always 1, and that plays into then, whereas before we just had 3x, 2x, because these were a coefficient of 1 and 1. So really you're just looking at 3 and 2 to give you 5, multiply together to give you 6. You're looking at negative 9. These numbers never change. But if we tack on a different number here, then it's no longer just looking at the 3, it'd be 3 times something else. And so it becomes a little bit more challenging for that. So here, I call it the guess and check method. There are some algorithms, which all that means is a kind of, not a formula exactly, but a method to factoring these. I have taught that a couple times. I've had other students say, hey, in my school, I learned how to factor this way, and I want to show the class how to factor, and then they show this process, and if it's this, then you do that, and if it's that, then you do this, and then if it's not this, then you do that, and then you plug in this and this. It ends up for me, and I've experienced, and I could, everybody's different, but it ends up being complicated, and students are confused, and they're like, it'd just be easier to guess and check. If you find another method, you're like, I went online and I found a way to do it. Okay, wonderful. Good for you. 2 thumbs up. Do it that way. I'm not angry. It's wonderful. And why don't you present it to the class? It's awesome. So if you find another way, or your parents are like, I remember doing this, and we did this, this, and this, and it's so easy. Why doesn't he do it that way? Feel free to do it your way and your parents' way, and feel free to show the class how to do it your way. I'm not opposed to it. So if we can come up with an easy way, I'm all in. If it's not easy and it's complicated, I'm not interested. But it may be easy for you, I'm all in. Okay? So, the guess and check method, we're going to do a few problems and work with this. And we're going to look at this. 2x squared plus 5x plus 3. So really the difference here is we see a variable in front of the squared term, a coefficient in front of the squared term other than 1. So we can no longer see here, if you kind of eliminate that and say, hey, what times what gives you 3 added together gives you 5? We would say prime, right? Well, the issue is it's no longer easily looked at and said prime because, it is not just 3 and 5 that we're dealing with. We're also dealing with the 2 out front here. So that plays into it. So what we're going to do is we're going to set up our factors the same way, but instead of just going x and x and I'm done, You can't do that because x times x is x squared. What do I need? I don't need an x squared, I need a 2x squared. So we have to consider the factors of 2 now. Now the nice thing about 2 is, how many options do I have? Only one option, right? It's 2x times x. So 2x times x gives me 2x squared. We're done there. The nice thing about the 3 is, for the back end here, is there's only one set of options, right? 3 and 1. So if you say, okay, 1 and 3, you can also figure out the plus plus, minus minus, or minus plus simply by looking at if this is both plus plus, what's going to go here? Plus plus. Okay. Now, you say, okay, great. 2x times x is 2x squared. 1 times 3 is 3. I'm done. Or am I? What do I need to check? Outwards and innards. So we say, okay, let's check our outwards and innards. 6x plus 1x gives me how many x's? 7x. Is that what I want? No. So if your outwards and innards don't give you that, then this is wrong. I'm going to leave it. I intentionally did it wrong. With practice, you can intentionally get it right. But you may have to do a couple tries, or you may recognize right away and say, oh, it should be this. So I can't change 2x and x. I mean, I could change and put the 2 here. Usually I don't. When it's only a 2x and an x option, I'll just leave that the same. 1 and 3, I can't change the numbers, right? 1 times 3 is 3, 1 times 3 is 3. There's no other options. But could I arrange the order differently? Sure, instead of saying 1 and 3, I could say what? 3 and 1. And the reason why that makes a difference is, when it's 1 and 3 like this, I was saying 2 times 3 is 6. When I change it, I'm saying 2 times 1 is 2. So I'm getting out different numbers when I change the 1 and the 3 around. So now I check, what's 2 plus 3? 5. So outwards and innards gives me 5. Did I get it correct? Yeah. This one is correct right here. Okay, so that is what I just call the guess and check. And sometimes the guess and check can take several rounds and become a little cumbersome. But usually we don't have too many options for it. Let me get it right here. Number 2. Let's give us one where we have to do a little more work. Actually, let's do this one. It's a 7m squared. We'll get a minus in there. Okay. Go ahead, see if you can do a guess and check factoring briefly, and I will get another problem ready, and then we'll go over this together. It's not prime, I'll give you a heads up. Some of them can be prime still for sure. In this case, it is not prime. You have to pay attention to the signs. You got a minus 9m and a positive 2. Again, do your quick check. And if it's wrong, you can erase it and try something different. I usually don't erase it just because otherwise I forget sometimes which ones I tried. And so I would leave the ones you tried that are wrong and then just cross them out like I did on number 1 there. Just so you don't forget, oh, I already tried this one. So hopefully most of us are getting 7m times m. Because that would give you 7m squared. There's no other options for 7m and m. It's just 7 and 1 are your only options for that. Hopefully most of us are getting 2 and 1. Because there's no other options for 2 and 1. The question is, where do I want to put the 2? Where do I want to put the 1? So do I want to go 2 and 1, or do I want to go 1 and 2? 2 and 1. Now, you might start catching on with a little bit of mental outwards and innards before you plug it in. If you do a quick mental thing and say, if I put a 2 over here and a 1 right here, that's going to give me 14 and 1. Well, 14 and 1 get me to a 9. No, so that's usually, as you start practicing, you're like, oh, 4, okay, that's not going to get me to a 9, so therefore let's go 2 and 1. If you don't recognize that, then you just have to do, again, a check, and then maybe mark it wrong for yourself, and then go to try the next one. Now, is it minus, minus, plus, 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 minus, minus, plus, minus, minus, because a negative times a negative, when you go negative 2, negative 1 gives you a positive, and then you add negative 7m minus 2m gives you negative 9m. Very good. So I don't know how we actually did on that, but we'll pretend we all got it on our own.
Yay!
Yes. Nice job. Okay. This one, a little bit different. 2 things are different about it. Well, a few things. C is a different variable, but that's not what I'm keying in on. 4, it now has options. What are your options? 2 and 2 or 4 and 1. So now you have multiple things that it could be. The nice thing about 3 is still just 3 and 1. But I tacked on, what's a little bit different is it's plus minus here. So if it's plus minus there, you are asking the question, what times what gives you a, what times what gives you a negative 3? Well, a positive times a negative gives you a negative. So if that's a negative 3, then you know you're going to have a minus plus, or you could say a plus minus. It doesn't matter. I just wrote minus plus, but that give you a heads up there. You're going to have a negative and a positive in there. So a negative something times a positive something gives you a negative. So go ahead, give yourself just a minute here and check with your support team around you on that check. Say, okay, what are you getting? Again, it could be 4 and 1, or it could be 2 and 2 for that first coefficient. And if you're not sure, just put one of them. There's nothing wrong with just saying, okay, 4 and 1, I'm going to start with that. Or 2 and 2, I'm going to start with that. Again, with a little bit of mental work, you could probably think through what it shouldn't be in certain areas. And then you just do a quick check. Do a FOIL check. If it foils out, fine. Back to the original, then you're set. We know we're going to have a C and a C, right? C times C is C squared. And then you're going to have a 3 and a 1. You just got to figure out where you might put it. Okay, let's, for the interest of just getting some more problems in, I'm going to show you something that's wrong. And you may have done this, and you thought you got it right, but it's wrong. I can look at this, and you're like, well, yeah, you've had practice, but you'll have practice, then you'll recognize. I can write this one and recognize that it's going to be wrong pretty quick. And I did it mentally. It's like, well, that would be wrong. And the reason for that is, I know 4 and 1 is 4, right? 4c squared. Negative 1 and 3 is negative 3. I know that. But the outwards and the innards, 4 and 3 is 12. 12 and 1 is not going to get me to a 4. So I recognize pretty quick, I wouldn't even bother trying that one. Now, you definitely can bother trying it as you're practicing. Like, I can't see that. Great. Just throw some numbers down and check it, okay? So, but I would look and say, yeah, 4 and 3 is 12. 12 and 1 will not get me to a 4. I would not have bothered trying that. As you practice, maybe you get to that point. So then our other option would be, though, you could say, okay, well, what if I just kept this and then said minus 3 and then plus 1? So I just switch the 3 and the 1 and then see what happens. You get 4. Again, all I'm really focusing on are outwards and innards because I already know this and this, check out, this and this, check out. So 4 minus 3 is not 4. So I've exhausted the options with 4 and 1. Therefore, I need to try what? No longer 4 and 1, but 2 and 2. So I say, okay, 2c and 2c. And then the question is, do we go 3 and 1 or 1 and 3?
1 and 3.
1 and 3. It actually doesn't matter because they're both going to be multiplied by 2, but we'll go 1 and 3. Now, for the sake of showing something wrong again, okay, if you will bear with me, I'm going to go like this. All right, now, I show this because you're going along, you're like, I don't know what to choose, I'm just going to choose. I'm just going to put something down, great. 2c times 2c is 4c squared, 1 and a negative 3 is negative 3, good. We do our outwards and inwards. Negative 6 plus 2, what's negative 6 plus 2? Negative 4. If you end up with the correct number but the wrong sign, we want a positive 4, we got a negative 4. If you end up with the correct number but the wrong sign, all you do is switch the signs. Okay, so you're like, oh nice, I got everything correct. It was just a negative 4. Done. I'm going to leave that up there just so we see. You just go like this. Just change the signs like this, and then now you're set. And then say, okay, that's wrong, but that's correct. So correct number, wrong sign, just switch the signs. All right, let's try another one with a double option on both. So number 4 here, we will go with 6h squared plus 17hk. I'm hoping that the double variable is becoming somewhat of a non-issue for you in factoring. That's my hope. Is it looks a little more confusing, but we remember, I mean, hopefully in this we go like this, we go like this, we go like this. We know we're going to have an h, we know we're going to have an h, and then we say what on the back end? In this case, k and k. All right, now it's taken care of. You don't have to like, oh, what do I do with the k squared? Just tack it on the back end there, and k times k is k squared, and it's taken care of. So in your trials, hopefully, on your guessing and checking trial and error, guess and check, that k squared doesn't throw you for a loop. The issue with this one is 6 could be 6 and 1, or 3 and 2. 10 could be 10 and 1, or 5 and 2. So we kind of have multiple options that we're dealing with that. Again, hopefully you recognize as you're doing it, one mental one to eliminate is if you chose 6 and 1 and 10 and 1, is that 6 times 10 is 60, which will be nowhere close to 17. So you can eliminate that trial if you can kind of mentally work through that, like I talked about for this one. And again, if you're not sure about the mental, trial and error, you can just start plugging in numbers. Start with a 6 and a 1, and a 10 and a 1, or 6 and a 1, and a 5 and a 2. This one is not prime. Okay, not prime. But hopefully, as you do this, you can at least get, and it may not be correct, but you can at least get what times what gives you 6 and what times what gives you 10. You can at least do that. We do like when it's plus plus, because what do we know our signs are going to be? Plus plus. We don't have to think about it too hard. All right. Who's got one for us? Whether it works or not, who put one? Giselle, what'd you put?
6h plus 5k.
6h and 5.
And then h plus 2k.
1h, I'm not going to write the 1h, but and then 2k. Let's just double check. 6h squared, yep. 5 and 2 is 10, k and k is k squared. So we got that. At least you could do that. Even if the outwards and innards don't match, that's fine. At least we did that. And then let's check their outwards and innards. 12 plus 5, right? 5 times 1. 12 plus 5 is 17. So don't need the second trial. Giselle got it on the first for us. Okay. You want to try one more, or are we doing okay with it?
We're good.
We're good? Okay, let's pause there and work on this one. You can see it just takes a little bit more effort on some of these. So a little bit more challenging. And brace yourself for 510.
Is this why?
That 510 is just brutal. Yeah, but we may do 2 days on it. I'm not going to promise anything, but we may.